Uh, in this video, we will see the second numerical method. Earlier we saw a numerical method of bisection method. Now we will see regular falsy method in this video. Earlier we saw the xi is equal to a plus b by 2. This is bisection method. Now we are seeing RF method, also called as regular false method. It is actually given by xi is equal to a into f of b minus b into f of a by f of b minus f of a. Here it is same, a and b, this is the number line, and like f of a is less than 0 and f of b is greater than 0. If we have something like this, and then with the help of regular falsy method we can compute xi. One important note is that with regular falsy we will have definite convergence. This is an important point. Now we will see some questions with which we will understand the things even in a better way. So question number 1, find the first approximation to the root of the function f of x is equal to x e power x minus 2 in between the interval 0.8 and 0.9. So x1 is equal to a into f of b minus f of a minus b into f of a by f of b minus f of a. An easy way to remember this formula is the numerator and the denominator both have the same thing, f of b minus f of a, like that, but in front of f of b the coefficient is a and in the coefficient of f of a is b. Now first of all, to do this we need to calculate f of a and f of b. Here a is equal to 0.8 and b is equal to 0.9. So we'll calculate f of 0.8 is equal to 0.8 into e power 0.8 minus 2 and f of 0.9 is equal to 0.9 e power 0.9 minus 2. If we can use calculator, and when we do this the value is minus 0.21 and f of 0.9 is 0.21. So what we see is on the number line, this is 0.8 and this is 0.9. So f of 0.8 is negative and f of 0.9 is positive. So we can apply RF method to find x. Now let us see what is the answer to this question. Now as we know that f of x is equal to x e power x minus 2. Now x1 is equal to a into f of b minus b into f of a by f of b minus f of a. Now substituting the value, here a is 0.8 and b is 0.9. This is 0.8 into, we'll also write here the other values. F of a is minus 0.21 minus 0.21 and f of b is 0.21. 0.21 minus 0.9 into minus 0.21 by 0.21 minus of minus 0.21. Now the answer to this question is 0.8506. You use calculator and then you will get this answer. So the value of x is 0.8506. Now if suppose if we find f of 0.8506, that is 0.8506 into e power 0.8506 minus 2. If we find this value, this is equal to 0. Therefore, it regular falsy RF method finds root for sure. So now we will see one more question. After that, I think this question will become very this method, RF method, will become very clear. Now second question, find first approximation to the root of f of x. Now here also f of x is equal to x square minus 1 minus sin x, and using RF method between 1.4 and 1.5. Now this is the question. Now a is equal to 1.4, b is equal to 1.5. Now as earlier, we will find f of 1.4 is equal to 1.4 whole square minus 1 minus sine of 1.4. Similarly, we will find f of 1.5 is equal to 1.5 whole square minus 1 minus sine of 1.5. This value, with if we use calculator, we will get it as minus 0.0254. This is a negative value, and this one, this is 2.25 minus 1 minus 0.9974. This is 0.2526. This is a positive value. So as we were discussing that we have a and we have b, f of a is negative and f of b is positive. Now I can use regular falsy. Now regular falsy xi is equal to f of b minus f of a. This is a into this is b by f of b minus f of a. Now we will see what is the answer to this. Now I am writing it down once again. F of x is equal to x square minus 1 minus sin x. Now a is 1.4, b is 1.5. F of a is equal to minus 0.0254 and f of b is equal to 0.2526. Now x1 is equal to a into f of b minus b into f of a by f of b minus f of a, that is equal to 1.4 into 0.2526 plus 1.5 into 0.0254 by 0.2526 plus 0.0254. The value for this is actually 1.4091. So this is the value of x. Now if we find if we can find f of 1.4091, then 1.4091 whole square minus 1 minus sine of 1.4091. This value, just use the calculator, and 1.4091 whole square minus 1 minus sine of 1.4091. This is almost equal to 0. So this is the answer to this question. I hope with these two examples this regular falsy method is pretty clear. Now in the next videos we will see Newton-Raphson method and other numerical methods which are generally from which questions in GATE exam generally